Okay, we are given y, a function with respect to x, but we are asked to find the rate of change of y with respect to time. So we are asked to find dy by dt. However, y being given with respect to x, we can write a chain rule. Dy by dt is dy by dx times dx by dt. So what is dy by dx? In order to be able to find it, we look at the y. Maybe it's easier if we rewrite y to cos x minus pi over 6 squared. And then, when we differentiate 2 times something squared, we get 2 stays times something squared. 2 times this something times the derivative of this something. Yeah, the chain rule. So practically dy by dx is going to be 2, the constant remains, times 2 goes down, cos of x minus pi over 6, don't need 2 sets of brackets, times the derivative of cos of x minus pi over 6. And though in order to find this derivative, we use again the chain rule, yeah, which is going to be minus sine x minus pi over 6 times the derivative of x minus pi over 6. This derivative inside it's 1, so it will stay the same. So dy by dx is 4 cos x minus pi over 6 times the derivative of cos minus pi over 6, which is minus sine x minus pi over 6 times the derivative of x minus pi over 6, which is 1. So we get minus 4 sine x minus pi over 6 cos x minus pi over 6. We are asked to find dy by dt, so we know that when x equals pi over 3 is required, x increases at a rate at 3 radian per second. So dy by dt when x equals pi over 3 equals dy by dx when x equals pi over 3 times dx by dt when x equals pi over 3. So we get dy by dx, if we replace pi over 3, we get minus pi sine pi over 3 minus pi over 6 pi over 6 cos pi over 6 times dx by dt was 3 minus 4 times sine 30 degrees is 1 over 2, cos 30 degrees is square root of 3 over 2 times 3. So we get minus 3 square root of 3 units per second.